Okay, number 16 here it says, at which points is the function continuous? Well, if I can figure out where it's discontinuous, then I'll know where it's continuous. Okay, first thing, a polynomial divided by a polynomial. This is another problem that I'm going to do in a minute. A polynomial divided by a polynomial is generally continuous because polynomials are continuous. Remember lines and parabolas? They're nice, smooth curves, right? They have no holes and nothing funny about them. They're easy, smooth graphs. The only place that it's discontinuous is what makes the denominator 0. That's undefined, right? So we got to figure that out. So we got to do a factorization, another quadratic. I think it's minus 5 plus 2. So if we have 5 or minus 2, it's going to be undefined, right? That's where it's discontinuous. So it's continuous as long as x does not equal negative 2 and 5. So that solves that problem. Let's look at 42. 42 says find b to make the function continuous. Let's just talk a little bit about it. We've got a linear piecewise curve. We've got a linear connecting into a quadratic. So some linear below minus 2. We got a linear coming up. Okay, some linear coming up. And it's going to connect to a parabola. Okay, it's going to connect to a parabola. I don't know, maybe like that. So we got to find the b that makes it connect. Okay? So this is just a little side note here on the picture of how it might happen. So as long as we're not at, I think minus 2, I think that's where it connects, right? That's the place that's troublesome. As long as we're not at minus 2, it's a nice straight line down here. All parabolas are continuous. It's just where they connect is the problem. So we need to figure out, so we want continuous at x equals minus 2. That means the limit has to exist at minus 2, the function value has to exist at minus 2, and they got to be equal to each other. So let's take the limit as x approaches minus 2. Well, as you approach minus 2, well, there's a left and a right side. See that? Because you're less than negative 2 and greater than negative 2. So the only possible way to do this limit is to break it into two pieces. From the right. And yes, I need to see limits. Do not do this problem without limits, or I'm going to mark it wrong. Okay, so the right side of minus 2. The right side of minus 2 is where x is greater than minus 2 up here. It has to be bx squared. So what's the limit of a polynomial? You just get to plug a number in. So it's b times negative 2 squared. It's 4b. The left side as you approach minus 2. That's x is less than negative 2. It's x. So you get to plug it in. Negative 2 for x, you get negative 2. So you see how we did the right and left? Now, for it to be, and then equal f of minus 2 here. Let's do it down here. That's this bottom part where you have the equal sign. You get to plug it into the bottom one. So that's b times minus 2 squared, which is 4b. Same as the answer on the first limit. Now, for continuity to happen, the right and the left have to meet. So these guys got to meet. So minus 2 has to equal 4b, which means minus 2 divided by 4. b got to be minus 1/2. So if b is minus 1/2, the parabola will meet the linear. They'll meet each other, like the picture shows. If it's not minus 1/2, they won't meet, and there'll be something like maybe a parabola up here, and there'll be a big gap. Okay? So that's kind of how you do 40, pretty much 41 through 46.